This video is looking at parallel plate capacitors. Parallel plate capacitors, or really any capacitor really, will help us store charge so that we could use it later even without a battery. So there's a capacitor that helps your phone store some charge so that that charge can later be expended as you scroll and swipe and call and text. So let's look at the most basic parallel plate capacitor and see what's going on. So we have two metal plates here, a plate on the top and a plate here on the bottom. Okay, and these plates are separated by some distance. I'll call it delta X, and let's hook these up to a battery. The battery has some voltage V, and as the battery runs, we build up some charge. So on the top, we get some positive charge because all the electrons from these atoms will run down the wire and move to this plate and build up some negative charge. Over here we'll have negative Q, and this is positive Q up here. The same amount of charge, just opposite signs. So any capacitor can store a given amount of charge for some voltage. A capacitor can store charge, and a certain charge, for a given voltage. Mathematically speaking, this is on the screen. Yep. A given charge will build up for the capacitance times the voltage. This is the charge stored on the plates themselves. This is the voltage difference, and if all we have is a battery hooked up to a capacitor, well, this is going to be the voltage difference between the plates. Let me be explicit here. And if all we have is this setup where there's a battery and two plates, well, this is going to be the same as the voltage of battery. And finally, that C is the capacitance constant. Capacitance constant. It's dependent on the physical properties of the parallel plate capacitor. Dependent on physical properties. We'll look at those later of the capacitor. The units for capacitance, well, we could look at our equation, rearrange this for C, and get Q over V. So one way of expressing this would be coulombs per volt. That's also defined as farad, which is F. So when we're talking about capacitance, we'll speak of farads. 1 farad is huge, so we'll typically talk about a picofarad or a nanofarad or a microfarad. This is the equivalent of 10 to the 12th farads, 10 to the 9th or negative 9th farads, 10 to the negative 6th farads. We might even speak of millifarads, which is 10 to the negative 3rd farad. Okay, I'm going to stop this and then pick it up in the next video about how the physical properties affect the capacitance of any given capacitor, which of course is storing up charge that can be used later.